In decimal numbering system, a single digit can have values from 0 to 9, that is, 10 different values. Once we have reached the maximum value 9 in a digit, the next increment will produce a carryover to the next digit, leaving the previous digit with 9 with a new value of 0, and repeating the carryover every 10 increments. This numbering system is 10-based, which means every digit represents a value multiplied by a power of 10. To get the amount a decimal expression represents, we take the value in the digit and then multiply it by the power of 10 that matches the position of the digit. And then every individual results are added together. So have a look at this number. We take the different powers of 10 and multiply each digit by its corresponding power of 10. These are the powers of 10. And this is the final result. Pretty easy, right? We call these units because these are multiplied by 1, these tens because these are multiplied by tens, these are called hundreds because we multiply them by 100, and the thousands, and then so on and so forth. Pretty easy, but it will help us to understand the rest of numbering systems that will follow. In binary numbering system, a digit can have just two values, 0 or 1. A binary digit is called bit. Say for instance we start from 0, then we increment to the next value that is 1. In the next increment, we will have to do a carryover to the next digit because we can surpass the value of 1 in a digit. So we have to do the carryover to the next and then increment again this previous digit and then do a carryover whenever we've reached the value of 1. And we can do this again and again till it's all ones. Let's have an example of a 4-digit binary number that is 4 bits. Binary number is a base 2 numbering system, that is, we use powers of 2. And we do the same as in decimal numbering system. We take all the values that every digit has one by one, and these are multiplied by the powers of 2. So we proceed like this. Remember that 2 to the power of 0 is always 1. Then to the power of 1 is 2, power of 2 is 4, and power of 3 is 8. And then we multiply every of these results. Remember that you can ignore the zeros and then just multiply and add all the results together, and then you have the corresponding decimal value. Now let's do a trickier one. This number is a 6-bit number, that is six digits, and we do exactly the same. We take the value of every digit and multiply it by the corresponding power of 2, and then add all of them together to get the decimal equivalent. In hexadecimal numbering system, a single digit can have up to 16 different values, starting from 0 to 15. The only difference is that numbers greater than 9 are represented by the first letters of the alphabet to make it possible to be represented by a single symbol. So we go from 0 up to f, which is 15. Then we do the carryover to the next digit. In this case, it will be 16. And then we start counting till we have reached the maximum value of f in this digit, and then we do the next carryover. And it will continue every 16 increments till it's all f's, which is the maximum value. Now let's take this hexadecimal expression. Since it is 16 base numbering system, we used powers of 16. So here we have, we're going to do the same as the other numbering systems. We take the value of each digit, and then we multiply this value by the power of 16, depending on the position of the digit. Remember that b is 11, so it's been replaced by the numeric value, and then we add them together just like in the other numbering systems, and then we have the decimal equivalent. Now let's do the trickier one. We do the same. We take into account the powers of 16, and then we multiply the value of every individual digit by its corresponding power of 16. Take into account that a has been replaced by its value 10 here, as well as c by the value of 12, just like in the table. So we multiplied all of these numbers, and we add the final results to get the decimal equivalent. In the octal numbering system, a single digit can have up to 8 values, starting from 0 up to 7. So we go to 7, and the next increment will do a carryover to the next digit, and leaving the previous digit in 0, and doing the same again till we reach the maximum value in every digit before doing the carryover. Let's take this octal expression and translate it to decimal. Remember, it is an 8 base numbering system, so we use powers of 8. So take the value of each individual digit and multiply it by the corresponding power of 8, and then add all of them together to get the decimal equivalent. Now this big number, it's to be done by the same procedure. Take the powers of 8, take each individual bit, each individual value of every digit, and multiply it by the power of 8, and then do the addition of all of them, and then just get the decimal equivalent.